And last, we have 6 for the x value. So we'll fill in 6 in the equation, and that gives us y is equal to 3. So we have the ordered pairs -3, -3, 0, -1, 3, 1, and 6, 3. We were told at the beginning to graph these ordered pairs. Graph the ordered pair solutions. Our table gives us 4 ordered pair solutions, which means that we must be able to graph those 4 points. So let's get the graph paper with the x and y axes drawn. Notice that the x-axis, the horizontal axis, has an x labeling it. The vertical axis has a y labeling it. Let's graph these 4 points. We first have -3, -3. From the origin, we count 3 to the left and 3 down. So there's our first point. -3, -3. Next we have 0, -1. 0 horizontally, 1 down. That gives us the point 0, -1. Next we have 3, 1. 3 to the right, 1 up. So there's the point 3, 1. And last we have 6, 3. 6 to the right, 2, 3, 4, 5, 6 to the right. 3 up, 1, 2, 3. And so there's the point 6, 3. So there our 4 points are. You may notice that these 4 points do come in a straight line. If I put a ruler down, the ruler will touch all 4 of those points. However, I'm not asked to connect the dots. We simply graph the ordered pairs that we found in our chart. Let me give you some exercises now. 2 exercises. Number 1, is 5, -3 a solution of 2x plus y equals 7? Is 5, -3 a solution of 2x plus y equals 7? Second exercise, graph the ordered pair solutions of y equals 5x minus 6 for x equals 0, 1, and 2. Graph the ordered pair solutions of y equals 5x minus 6 for x equals 0, 1, and 2. Copy these on your paper, stop the tape, work the problems, then restart the tape and check your answers. Your answers are, for the first one, yes, and for the second one, you should have the 3 dots, 0, -6, 1, -1, and 2, 4. Once again, we can see that these 3 points do lie on the same line. They would be touched by a ruler. We now introduce a notation called functional notation. For functional notation, replace y with f of x. F parenthesis x parenthesis. Read f of x. This is an unfortunate notation in one respect. It looks as if we're multiplying. This looks like an f times an x. It is not. It is not multiplying. We're simply using this symbolism to replace the letter y. This stands for the function of x, f of x. So, for example, when we have y equals 5x minus x squared. This becomes, when we replace y with f of x, it becomes f of x equals 5x minus x squared. So what we've done is simply replace the letter y with f of x. Well, why would we do such a thing? What we're doing is using a special notation that will become more and more familiar to you as you go through your mathematical career. This says that we have a function named f. X is a variable that's going to be used in it. To evaluate a function for a given x value, replace x by the given number and simplify. And this will be our task. To evaluate a function for a given x value, replace x by the given number and simplify. The x in our new notation, f of x equals something about x. The x appears on both sides of the equation. The x appears on the left-hand side inside the parentheses, and the x appears on the right-hand side somewhere in the problem. In this case, it appears twice in the expression that we're to use for f of x.